I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very interesting question based on limits and continuity. The question here is, can the limit exist at x equals to a if x equals to a represents a hole in the graph of the function? Note: provide an example to support your answer. So these are open-ended questions which help you understand the topic better and communicate while answering such questions in test papers. In case you want to learn from me, you can always send an email on the address given. So let's try to understand the question. We want to figure out if the limit exists at x equals to a and at x equals to a we have a hole. It will be good if you could visualize it, correct? So let me write a function and then we'll visualize. Consider a function which has a hole. Hole really means that you will have a common factor in numerator and denominator. So here is a very simple function for you. You could write x squared minus 1 over, let us say, x minus 1. Well, this could be written as x plus 1 times x minus 1 with x minus 1 in denominator also. So clearly, you can cancel one of these factors, and therefore you can now write this as x plus 1, where x is not equal to 1. Now at 1, we have a hole. So that means there is a hole at x equals to 1, correct? What is the y value of this hole? If I substitute the value, I get 1 plus 1 as 2. So I can say that y value will be 2. Correct? If I have to sketch this function, how will it look like? We have a hole at 1, 2, and the function now is x plus 1. So let's rewrite the function here. We have a function f of x equals to x plus 1, where x is not equal to minus 1, since we have a hole at minus 1, 2. So x plus 1 means a graph which will be with y-intercept of 1, slope of 1, correct? So kind of like this, right? So that becomes the hole and it continues. So that is the graph for the function, and clearly we have a hole at x equals to 1, y being at 2. So I hope till now the concept is absolutely clear. Perfect. So at this stage, you can actually pause the video, answer, and then look into my suggestions. Let's continue. To show that the limit exists, what we need to do? We have to find limits from the left side and from the right hand side. So that means we have to find limit when x approaches, hole is at 1, from the left side of this particular function. And we have to also find the limit when x approaches 1 from the right hand side for the given function. Well, if you look at the diagram from both the sides when you approach a value which is y equals to 2. So both these values are indeed 2. You get an idea, right? So this means that both of them are equal. Since the limit exists and limit from both the sides is exactly same, we say that the limit exists. Let me rewrite this as limit x approaches 1 for f of x is equal to 2. So it exists. You get the idea. So now we can conclude that the limit will exist at x equals to a if x equals to a represents a whole. Perfect? As shown here. So it does exist. Now, I would like you to provide another example and figure this out. Well, we could do with a graph, let us say, very similar to what I took. Let's say a graph like this. And we could have a hole at x equals to, let us say, in this case, also at 1. Okay. You could write a function for this and then conclude your results just as I did. Now here is a hint. Your function in this particular case can be written as, since the end result is 1 over x and we see that the whole exists at 1, let us say, right? And let's say this value is also 1. In that case, we can say x is not equal to 1. You get the idea. So that could be the function for the given graph. Well, you could actually do backward calculations and write down the function f of x also as equal to, since we have a hole at x equals to 1, there was a common factor x minus 1 which got cancelled. You get the idea, right? So in this function, we have to know that x is also not equal to 0, since at 0 we do have a vertical asymptote, correct? So here we have a rational function which is not equal to 0 and also not equal to 1. I would like you to pause the video, use this as your function, the diagrams given before you, and show that the limit exists at a whole. I hope that makes sense. Feel free to write a comment, share your views. And in case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.